Hello students, how are you all? I hope you all are doing good. So today I'm going to discuss conformations of ethane. This is my hydrocarbon part 5. So let's start conformers of ethane. Okay, this is our topic. Conformers or conformations of ethane. Okay, now conformations in very simple language, you can say conformations are nothing but the different form of ethane, or we know that in ethane we have two carbon atoms. C2H6 is the molecular formula. How these two carbon atoms are arranged, and how three hydrogen around each carbon atoms are arranged, how we can change change their position by rotating with some angle, known as a conformation. And under this topic we are going to talk about the stability of the conformers. Okay, different forms. So let's start today's topic, conformations of ethane. Okay, now when I'm going to say ethane, the question should come in your mind, why not methane? Or does methane also shows conformations? Very good question. So you can write a point, methane. The molecular formula of methane is what? CH4, correct. Right? Methane does not show conformation. What is the reason behind that? Because to show or to make any conformer, we need at least two carbon atoms. So conformations starts from ethane because ethane has two carbon atoms. Okay, so during conformation there is no change. During conformation there is no change in bond length and bond angle. There is no change in bond length and bond angle. Very important point, very interesting topic. Definitely you will enjoy. So stay with me, keep your notebooks ready, start writing notes with me. It's going to help you a lot. Promise me, believe me, it's going to help you a lot during your exam time. Okay, so conformation of ethane. Ethane is C2H6. Methane does not show conformations. Reason, it has only one carbon atom. We need minimum two carbon atoms to show any conformations or to make any conformers. Okay, so during this conformation, during this change and the rotation, there is no change in bond length and bond angle between carbon and hydrogen, and carbon bond length, carbon and hydrogen bond length. All right, now so here, now when I'm saying conformations, means two different forms. So suppose for example, if I say A form and B form, okay. Now suppose if I am saying ethane shows form A and ethane shows form B, means these two forms are interconvertible. Please make a note, children. So here these two conformers or two forms, they can interconvert into each other. They have very less energy difference. Means if I give little heat to A, conformer will change to B and B to A. So this is the reversible sign. Okay, they are interconvertible. This is the third point. These two conformers are interconvertible. Okay, is this clear? Right, now let's make conformers of ethane. Okay, so we know that it has molecular formula C2H6. This is my one carbon atom, this is my another carbon atom. Okay, so C2H6 I can write as CH3. Okay, so here one hydrogen one hydrogen, one hydrogen, one hydrogen, one hydrogen and one hydrogen. This is my ethane. Alright. Now here sigma bond, carbon carbon single bond is sigma bond length will be 154 picometer. Okay. Now what I'm going to do to make a conformer, I'm going to use or I'm going to fix this carbon atom and I'm going to rotate this carbon atom. Okay. Now by fixing the position of alkyl group, we can rotate the another. So here I'm going to fix this and I'm going to rotate this carbon atom, and by rotating we are going to get the conformers of ethane. Okay. So when you do the rotation, okay, when we do the rotation of ethane, we get two, when we rotate the ethane, we get two conformers. Okay. The first form which we get is known as eclipsed form. Okay. The first form, the first conformer of ethane, the form is known as eclipsed, and second staggered form, and second is staggered form. Okay. Now I'm saying one form, one I have kept fixed, one I'm rotating. Okay. So when I rotate it, the position of these two hydrogen will be changed. The position of this hydrogen will be changed. But in between eclipsed and staggered, we get number of phases. Like for example, if you have learned about the phases of moon, so between the full moon and the no moon stage, we have different phases of moon. In the same way, ethane also has eclipsed form and staggered form, and in between these two forms, ethane also has different forms, different rotamers, that is known as skew. Okay, that is known as skew, the in between form of eclipsed and staggered. Is this clear, children? Any doubt till here? If you have any doubt, please do let me know in the comment section. I'll clarify your doubts. Okay. Now, so eclipsed and staggered form we can represent by two ways. What these two ways are, let's discuss. Okay, eclipsed and staggered form can be represented by using two ways. The first way, make a note, these two conformations can be represented by two ways. And what are these two ways? Number one, we can use Sawhorse projection. Okay. And another we can use Newman projection. Okay. So by using Sawhorse projection and Newman projection, we can represent conformation of ethane. Okay. Now, to explain Newman projection, I am going to make the model, and by making model, it will be very easy for you to understand. Okay. So we know that carbon is black in color. So I am going to use a bead which is black in color. Okay. Let's take out the black bead. We need two carbon atoms to make ethane. Okay. Okay. So I have taken two carbon beads. Okay. And I need total 6 hydrogen. So we know that the structure or the size of hydrogen is smaller than carbon. So I am taking white beads which are smaller than carbon. Now, apart from these two atoms, two types of atoms, I need to make single bond. So these are the single bonds, children. I'm going to make single bond. Now, carbon-carbon single bond is larger or bigger than the carbon-hydrogen bond. So I am taking 6 bonds for each, so for 2 carbon atoms. So I have taken 1 bead. Okay, I'm going to make a bond between these 2 carbons. I hope you can see this clearly. Okay, now I need to arrange this. Okay, so before this I'll draw this on the board. So first we are going to do the Sawhorse projection. So let me erase this. It will be easy to see and to understand. Okay, so here first is Newman, Sawhorse. Not that, we are not seeing any horse. We did not see any horse. Sawhorse projection. Okay. All right. In this is my carbon. This is my one of the carbon. Okay. What I drew before, this hydrogen, this hydrogen, this hydrogen. This is carbon-carbon single bond whose bond length is 154 picometer sigma bond. Okay. Now, the bond angle between HCH is 120 degree. Okay. Here also, like for all three, 120, 120, 120. Okay. Now let's make now see this. Does it look like this? Does it look like this? Okay. Now you can see this. This is your carbon 1. I told you I'm going to rotate. Okay. Now this carbon atom, the first carbon atom, I'm going to fix it and I'm going to rotate this carbon atom. Okay. So I'm going to turn hydrogen by 60 degrees. Okay. Yes, you heard me correct. I'm going to rotate this hydrogen by 60 degree and let's see what happens. Okay. Now, what happens here when I rotate it by 60 degrees? Okay, I kept this carbon atom as a fixed position, at a fixed position. So I kept it, I'm drawing the same carbon atom at the same position because you can see 1 hydrogen up, 2 hydrogen down. Okay, and carbon-carbon single bond, carbon-carbon single bond. Now you can see 2 hydrogen came up. So 1 hydrogen here, 1 hydrogen here, and 1 hydrogen down. So 1 hydrogen down. Okay, children. So this form, which was that form I'm talking about, this form when both on the same carbon, on the both carbon atom, 1 hydrogen up and 2 hydrogen down, that is known as eclipsed form. That is known as eclipsed form. And after rotating, when for one carbon atom, 1 hydrogen up, the other hydrogen atom, 2 hydrogen atoms will be up. Okay, so for one carbon atom, 1 hydrogen up, the other carbon atom, 2 hydrogen up, that form is known as staggered form. Okay, now the question should come in your mind, out of these two forms, which one is stable? Okay, out of these two forms, one form is eclipsed, one form is staggered. Out of these two forms, which one is stable? So yes, one more question, staggered form is more stable than eclipsed form. As I told you before also, these two forms are interconvertible. Very less amount of energy required to change from one form to other forms. These are called the conformers. Okay, and the complete process is nothing but the conformations. Is this clear? Any doubt till here? Okay, we can represent the same thing with the dot diagram. I can also draw this way. So this center dot is representing carbon and center dot representing other carbon. This is your staggered form, eclipsed form. Okay, and this after rotation, this is your staggered form. Clear? Okay, upside down Y and the normal Y. Clear, children? I hope it is clear to everyone. Now, next conformation, as I told you, we can represent conformations of ethane by two ways. This is our first way, which is known as Sawhorse projection. And the next is Newman's projection. Okay, have you noted it down? Can I erase it? All right. Next is Newman's projection. Next is Newman's projection. Newman's projection. Okay. Now, how we can use or how we can make conformations of ethane by Newman's projection. So what he said, first I'll draw then I'll explain to you. This is one carbon atom. Okay. And each carbon atom has etched, right? And one more carbon atom which is far and has hydrogen, hydrogen, hydrogen. Okay. So this is one carbon atom like this. Still like this. Okay. So when you close one eye and if you see, you can clearly see that this carbon atom is hiding this carbon atom or overlapping this carbon atom. This hydrogen is overlapping this hydrogen. This hydrogen is overlapping this hydrogen. And this hydrogen overlapping this hydrogen. Can you all see this? Okay. So you need to check this model by closing one eye, and you have to see with one eye and see how carbon is overlapping the other carbon atom. Okay. It is like this. Okay. Like this. Okay. So this form where hydrogen has the same position, known as eclipsed form. Okay. But when you rotate, again rotation, when you rotate, I hope you all can see six hydrogen atoms very clearly. One at the back side up, two in the front, one in the downwards, and two other at the back of first carbon atom. So this is the carbon atom, hydrogen, hydrogen, hydrogen. This is the another carbon atom. This is your staggered form. This is your staggered form. Okay. Clear? As I told you, we rotate it by 60 degrees. So when you rotate, you will get this kind of structure. This. Okay. Now you can see that. Okay. This kind of structure. Okay, children. Any doubt in this? Now, relative stability of the conformations. Out of these two, which one is stable? As I told you, out of Eclipsed and Staggered is more or most stable. What is the reason why this is more stable? Why Staggered is more stable? Staggered form is more stable. Okay, more stable due to less repulsion. Yes, due to less repulsion. Important, very, very important. What type of repulsion I'm talking about? See here, children. So if this is my staggered form, right? So here hydrogen has positive charge. Definitely if this hydrogen is like in this form, in the eclipsed form, same charge, we know that they repel to each other. Same hydrogen, they'll repel. Same hydrogen, they will repel. This is your eclipsed, with the repulsion is maximum. But once you rotated it by 60 degrees, now you can see one here hydrogen, there is no other hydrogen, so repulsion is less. One hydrogen here, in between these two hydrogen, there is nothing, so repulsion is less. One hydrogen between these two hydrogen, repulsion is less. Due to less repulsion, staggered form is more stable. We know that stability is inversely proportional to its repulsion. If the repulsive force is more, molecule will be unstable, right? So you can make a note for this. Here I'm making star mark, that stability of any molecule is inversely proportional to repulsion. Okay, is this clear? Okay, now here repulsion less. As I told you, staggered is more stable, so repulsion will be less, stability will be more. As inversely proportional, I hope you know this. If anything is inversely proportional, so if stability is going to increase, repulsion will be less. Repulsion is more, stability will be less. Well, in case of eclipsed, more repulsion, so you can write it here, repulsion more, stability less. While in case of this staggered form, repulsion less, stability more. Clear? Now, as I told you, these two forms can be interconvertible, right? Eclipse can change to staggered, staggered can be changed into eclipse. Why? Due to very less energy gap. They do not have very much energy difference, because if any conformer has a very good or very high amount of energy gap, it's very difficult to change the form from one form to other form. But as eclipse and staggered, they have very less energy gap, so they are easily interconvertible. Okay, how much the gap energy less, as I'm telling, very less, so you can make a note. They have 12.5 kilojoules per mole. This is the energy gap they have, which is not very high amount. So 12.5 kilojoules per mole energy gap they have. So eclipse can easily convert to staggered, staggered can easily convert to eclipsed. I hope you understood this topic. So here we have done with our alkanes. Any doubt? If you have, please write in the comment section. Don't forget to like, subscribe, share, and comment to my channel. Till then, see you. Bye bye.